So for the final test, I'm going to turn off the align me and then remove the power cable from the align me and move it to the run well drive. And I'm going to go to motor, final test, connect to the drive through the Ethernet cable, make sure the IP address matches what's scrolling on the front of the run well drive. It should always, once you enter it once, unless you've done a software update or changed it, something like that. So in this case, it does. We'll click connect. We're going to program the drive with some basic motor parameters that are usually found on the nameplate of the motor. So in this case, it is 6.1 amps, 4.18 Newton meters with a max speed of 3000. And this does have a 24-volt break on it. And then the lock-in is predefined based on our drop-down selection up here and the motor that was identified. So if you're not familiar with the final run test, the analytics time is defaulted based on the number of encoder channels that have to be analyzed. So in this case, it's a 5-channel encoder. So it's going to take a total of 10 minutes doing analytics tests before and after the free runtime. So this will cost test minutes. The runtime does not cost test minutes. So normally I would let a motor run for 30, maybe even 60 minutes, depending on the size of the motor. Smaller motors will heat up more quickly than larger motors. So this one, it would probably run about 40 minutes maybe. In this case, I'm just going to leave it at 1 minute because this is just a demonstration. And the test speed, we're going to run it at 1,000 RPMs for that 1 minute. And we can leave the acceleration and deceleration speed there. All right, so now we can click configure drive. I'm going to secure my motor to the table here. So I can't get much of a better camera angle than that. All right, and then I will hit clear faults to make sure that the drive is not in a faulted state. And then once I click enable access, we will be injecting current into the stator windings of the motor. So the shaft may jump, which is why you want to have the motor secure before you click enable access. And then once I hit start collection, the final test run will begin. So I'm not going to run this test to completion. I'm going to show you the beginning of the test, just to look out for a couple things that are unique to an encoder that uses a commutation offset for an alignment as opposed to a mechanical alignment where you're looking for that 0 degrees. So we'll kind of let it get to the first analytics part, and then we'll call that good. And again, if you're not already familiar, the calibration sequence of the final test is just the Linea X3, the drive, and the motor feedback all syncing together, making sure that it's reading the way it's supposed to. We're getting communication. Like the speed of the motor shaft is congruent with the speed of the encoder shaft, making sure everything's synced up, basically. All right, so now the Linea is reprogrammed the drive to do a commutation check, which you can see right here. Now, again, for a mechanical alignment, the expected value would be 0, as in 0 electrical degrees, and it would be looking to find 0 at that U positive, V negative lock-in angle. In this case, it is looking for a 37 comm offset value. And on a 4-pole pair motor, it's expecting to find that value at 4 different points in the rotation. So you may notice that commutation offset value isn't the same as what we found when we performed the lock-in. That's because it is actually checking a different lock-in angle, not the U positive, V negative, but it still verifies the alignment. It was our 82, we just passed it. All right, so that was the commutation check. That's how you know that the alignment is good. If for some reason the alignment was bad, we would get a commutation test failed message, and then the software would reset before moving on to the amperage stage or the analytics stage where our test minutes are actually being used. So since it passed the commutation check and we know the alignment's good, now it is getting amperage information from the stator windings themselves, as you can see down here. That'll be included in the final test report. That's something unique to the final test where we actually pull the current data from the UV and W phases and measure them for symmetry, amplitude. There's a pretty good stator check to determine the health of your stator. All right, and now it is actually doing analytics on the encoder itself. It is going to spend 1 minute on each channel with the encoder, and it is going to perform that check here. And it's also going to repeat the steps that we just observed, with the exception of the amperage check, at the end of the free runtime. So right now it is doing analytics on the encoder channels while the motor is cool or at room temperature. And then after the free runtime, which again would be long enough to get the motor in the encoder nice and hot, it'll do an analytics check after that as well to make sure that there's no heat-related failures with the encoder. So as it goes into that free runtime, that's when you'll listen for like bearing noise, brake drag, anything like that. And then once this whole test completes, you'll have another pop-up to fill out to generate your final report, which again, just like the analytics report from the last video, is automatically saved as soon as you generate it. But you can also save it to a PDF to store it with your job folder or email it to a customer, anything like that. So again, I'm not going to make you sit through the entire final run test on this one because it is a 5-channel encoder. It's going to take a little while, but that is pretty much the gist. So that's how you do the incoming checks for the SICK Hyperface, and then that's how you program memory to it, and then perform the alignment after you have memory programmed. If you do have any questions, we are always available at support@octavaengineering.com. So please don't hesitate to reach out to us. Like I mentioned in the last video, even if it's a situation where an encoder comes in dead and you don't have a memory file saved from a previous job, if you need help with a memory file, something like that, please let us know. If we have it, we're more than happy to share it with you. So thank you for your time, and we'll see you on the next one. We are always available to help. Just shoot us an email at support@octavaengineering.com. And I thank you very much for your time.